We made the decision to not go after these synthetic libraries of compounds. We made the decision to go search the epidemiological data, search papers that were out there for botanicals that had reported cognitive enhancing effects.
The first positive thing that people saw with coffee drinking very early on was that people who tend to drink coffee don't tend to get don't tend to get Parkinson's disease.
For women, there's about a 60% reduction in getting diabetes, type 2 diabetes. There's about a 30% reduction in getting Alzheimer's disease. And that reality is one of the reasons why we went and looked at coffee.
People have tried to develop drugs for caffeine because it's generally been assumed that caffeine is the major beneficial effect from coffee. So we looked to see if the compound we identified, EHT, would have that effect. And those were our first experiments were with Parkinson's.
As Jeff had mentioned previously, we believed or hypothesized that because of the centrality of the mechanism that Jeff has been studying and that we've been studying and that our technology is based around, which is PP2A, which is this enzyme, there would be things in everyday life that people are consuming that would affect that target. And because of the reality that coffee has those effects, we decided to go after coffee and screen it against this mechanism. And lo and behold, it was active. It clearly, in a very robust way, affected PP2A in a positive way.
What we think EHT does, and in a biochemical sense, it interacts with PP2A and helps to keep PP2A healthy and helps to maintain this whole regulatory apparatus in the right way. And so it could be a generally useful molecule, and the first one we've identified, I think we'll be able to identify more that may have a general effect to prevent aging and help performance and help healthy people be a little bit more healthy.